Earlier we had reachability between R1 and R2. Now we have added another customer called new. New and 1, they are in same PE router. 1 is a customer, which is R1. New is another customer, which is R7. They both are connected to same PE router. So what do we need to keep the routing table separate? We need to create another VRF called new now. For that, I have given a route distinguisher 2:2. For the same customer on the remote router on R6, I've given different name and different route distinguisher just to prove you that name and route distinguisher are locally significant. And if you notice the route target on either side for VRF new customer, VRF new is same, 10:10. When we don't mention import or export, it means both. 10:10 is for both import and export. And also I have done something here to teach us that subnets of one customer can also be seen in another customer. That won't conflict. Subnet of one customer can also be seen in another customer. That will not conflict. See here, 1.1.1.1. It is on router 1 as well as on router 7. It won't conflict, two reasons. One, it is getting into different routing table. On router 3, it is going to be learned in new routing table, not one routing table. Routing table called new. And in the VPN, the route target attached to that 11111 coming from router 7 is 10:10. Whereas the route target that is attached to 11111 coming from router 1 is 111:111. What do I mean by this? You might have already understood, but let me explain you more for clarity. This network, when it goes in the VPN, it will be like this. This export value, no? That same 111 number is same, but it is coming from different customer. It will be like this. Does it look same? Definitely not. In the VPN, our 32-bit address will not be 32-bit. It will be this 32-bit plus this 32-bit plus this another 32-bit. Totally 96-bit. This is one 32-bit, this is another 32-bit. I told you route targets are 64-bit value. So this route targets along with the prefix 32-bit will be 96-bit. When you compare these two 96-bit, they are not same. This is 1, 1, 1, 1, 10, 10. Whereas this one is 1, 1, 1, 1, triple 1, triple 1. They're not same. Alright, so let's do and see. The transport for both VRF1 and VRF new is same. The transport is same. The service tunnel is same, but the VPN ID is different. Means route targets are not same. So they won't conflict. Now let me start from router 7 because this is the one which we newly added. And the autonomous system for this is 700. Okay, we have this R7 ready. Let us alter this configuration that we used in R7 and finish R8. BGP is going to be 800. Remote is the same 10 and network that I'm advertising here will be that's all. Okay, thank you. We'll do it. Alright, so router 8 is ready. Router 7 is also ready. We need to bring router 6 and router 3. Before that, let me add this autonomous system numbers. I'd like to show you that BGP has already got some network in the VPN. Show IP BGP, no, not IP, show BGP, VPN v4, unicast, all VRF. See, this proves that we already have network reachability between router 1 and router 2. How do I know that? You see, this is router 1's network. This is router 2's network. Autonomous system 100, autonomous system 200. So I'm very sure R1 will be pinging R2. I can show you once before I go further. It pings. Same like this. I should be able to ping between router 7 and 8 if I put these configurations correctly. So going to router 3, I'll start first by giving IP address under the VRF interface. For that I need VRF, so I'll say IP VRF. The name that I gave is new. Route distinguisher should be different from the early one, the previous one. So give 2:2. See, in some iOS there is an auto option. Auto. Here in this iOS we don't. Some iOS, if you say auto, it will generate a number which is not previously used. That's very nice, no? Auto. Now I'm saying 2:2. Next route target, I'm giving 10:10. When you don't say import or export, it will be for both. What is the verification There are two places you can verify. Show RAN section IPVRF. Here also you can see. You see, we did not say for new export, import. We did not say that. It's taken automatically. You can also type by type and see show IPVRF detail. Here for VRF new export is 10 colon, import is 10 colon 10. And the interfaces assigned to this VRF are none. No interface. Let's go and assign an interface. Go to router 3. Interface G4/0 IPVRF forwarding new. Put the IP address that is needed here. It is 7373 3. And then I need to go under VRF BGP. VRF BGP. Like router BGP 10, address family IPv4 VRF new. And then I have to say neighbor is 73.73.73.7. Remote AS is 700. This 700. And then I also should check now whether these routes are seen in the VPN as well as the routing table. I'm waiting for the neighbor to come up first. If the neighbor is not coming, I have to troubleshoot. Show IPVRF. I have the interface correctly assigned. Show IP route VRF new route. I suspect that the interface is down. Show IP interface brief G0. Look at this. Administratively down. G4/0 no show. Now, yeah, now over the tunnel you can expect the network. If I'll go to router 6 now, I'll go to router 6, I'll be learning these two networks. Let's see. So if I can see in 6, I don't need to check in router 3. Show BGP VPN v4 unicast all. Look at this. I don't see any. I don't see any routes updates coming from Autonomous Systems 700. The reason is we don't have a VRF to import it. So let's create VRF. Let's configure VRF. VRF name is, I'm giving different name to show that for the same customer I can have different name. IPVRF new _cast. RD can be say different or same, that doesn't matter. I said 22 colon 2 here, whereas the other side we say 2 colon 2. And RT should match. After saying this, even though I have not assigned any interface to this VRF, you will see the route in the VPN. You see, there is no even interface assigned, but VPN is attached already. You see, this is what I said. From 700 autonomous system, I'm learning 11111. Earlier we were learning 11111 from 100 also. Now we have both. If you see now, show IP unicast all 1.1.1.1/32. Now you will see the 1.1.1.1 is like this. It looks like this. You see 96-bit value. And it is attached, it is coming from autonomous system 100. And this is again another 96-bit value. For the route 1111 coming from 700 autonomous system. And while going, if you see the route target values are like this. They are not same. So there is no conflict, even though the address is same. Now what next is I'll just form BGP between these two, and I'll be able to ping from router 8 to router 7. So going back to router 6, one more time I want to check the routing table, show IP route VRF new underscore cust, which we just created. These two are learned from autonomous system 700. We got another VRF, no? TWO. This is TWO routing table. I want you to compare both. This 11111 has got an X-stop 33333. This also has got same 33333, but they will not conflict because the route targets are not same, and the route distinguisher, which is local, also not same. This is VPN termination point, you see. For router 6, this is the VPN termination point 33333. Transport. Let us quickly verify this, but before that I have to form neighbor between R6 and R8. Router BGP 10, address family IPv4 VRF new underscore custom neighbor 86 86.86.8 remote AS is 800. That's all you need to do. Now this 888 will be advertised to 77 router 7. Let us go to router 7 now and check whether we are learning 8. On router 7 I should be learning 8.8.8.8 which means VPN is good. Show IP route BGP. No. Show IP BGP. I advertise, but I don't learn anything. You need to wait. Let's go to router 8 and check whether we are advertising it. Show IP BGP. We do advertise this. Show IP BGP summary. Oh, the neighbor is not up. Why? I think I have not assigned the interface in R6. Let me quickly check. Show IP VRF. No interface assigned. So interface G4/0 no shut. IPVRF forwarding new underscore cust. IP address 86, 86.6. Done. Okay, see the BGP neighbor has come. Now I'll go to router 7. Okay, you see you got this from autonomous system. Sorry, this 888 from autonomous system 800, and it was traveling via autonomous system 10. So if I do now the trace route to 8.8.8.8 with a source 11111. Look at this, the two labels and the path. So it works. The VPN is up. And I'm going to ping and show you once. Pingo, ping, ping. Now, one more test I would like to do is I'll go to router 8 and trace 11111 with the source 88888 to show you that it will not go to router 1, it will go only to router 7. See, it goes to router 7. When I trace route, it goes to router 7. Same trace, I'll trace from router 2. Same thing, I'll do it from router 2. It will go only to router 1, not to 7. See, this goes to router 1 when the destination is 1111. Whereas router 8 goes to same 111, it goes to 7. So though they are tracing the same destination, but it is not really same destination. The address is same. They're not same destination. They don't belong to the same customer. This is another advantage of layer 3 VPN. Customers can have same subnet. There won't be a conflict. There won't be any conflict. Customers can have same subnet. Right, so I have shown you layer 3 VPN with 2 customers today. Do you have any question? Yeah, that's good. All right. So I'll produce the video once it is ready for you to use. Watch it till you get it, do it, and come. We'll learn some more advanced thing in MPLS. So once again, let me remind you, it is route target, the one which keeps the customer routes separate in the tunnel, even though the subnets are same. And it is the VRF name and the route distinguisher that keeps the routing table and the route separate locally on the router.